Okay, let's dive right into this. So, over the last 6 days, you've learned the core building blocks of artificial intelligence. But today is the really empowering moment where everything finally clicks together. You know, understanding AI in theory is one thing, but actually connecting all those individual pieces into a real, functioning system, that's where the magic happens. That's where it truly starts to make sense. Welcome to day 7. In this explainer, we're shifting gears. You're no longer just memorizing definitions. Nope. Today, you are going to design your very first AI model concept, right from start to finish. Let's get into it.
Here's our roadmap for the day. We'll start off by connecting the AI puzzle, then jump into the spam classifier challenge. After that, we'll blueprint your AI system, walk through the training and validation steps, define what true AI success actually looks like, and wrap up by learning how to think like a designer. All right, first up, connecting the AI puzzle. Let's do a quick Week 1 review. Let's quickly connect the dots with a rapid-fire recap of your whole inventory from this past week. Day 1, we defined what AI actually is. Day 2, we uncovered how machine learning works. Day 3, we introduced neural networks, and Day 4 took us deep into, deep learning. Day 5 covered how to train, validate, and test, and finally Day 6 explored loss functions and optimization. Now, what's really cool about all of this is how each topic is literally just one piece of the exact same puzzle. It brilliantly shows us the core pipeline, right? AI starts with data, it learns patterns from that data, it improves by making errors, and it gets rigorously tested before it ever sees the real world. Moving right along to Section 2, the Spam Classifier Challenge. Let's get into our mini project. So we're going to build a simple model concept around a classic, incredibly important AI problem, classifying emails as spam or not spam. Honestly, it's one of the most foundational AI problems out there, because it's super easy to understand, but it forces you to use almost every single concept you just reviewed. As you can see, we've got a classic binary classification problem. On the left, we've got spam emails, you know the ones, suspicious wording, strange patterns, all that junk. On the right, normal user behavior. Now keep in mind, our goal today is not to write a single line of code. Not at all. The goal is to design the entire AI thinking process.
Okay, Section 3, Blueprinting Your AI System. We're looking at steps 1 and 2.
Step 1 of your blueprint is simply figuring out what data do you actually need. Your model needs a massive amount of example emails to learn from, some clearly labeled as spam and others labeled as not spam. But the AI can't just read an email like we do. We have to extract specific elements from those emails. Look at the list we've got here. We need to pull out subject lines, sender info, word patterns, links, punctuation, even the number of attachments or previous user behavior. In the AI design world, we call these specific extracted elements features. These features, they are the absolute raw fuel for your model. Step 2 is designing the network architecture itself. And a simple neural network is absolutely perfect for this. Let's map out exactly how the data flows. First up is the input layer. Think of this as the front door. It receives all those features we just talked about, like the links and the word patterns. Next, the data moves inside into the hidden layers. This is really the brain of the operation. It's where the network actively hunts for suspicious wording, strange sender behavior, and those repeated hidden patterns. And finally, the data gets pushed to the output layer, which basically forces the model to make its final call. Is it spam or not spam? All right, let's move to Section 4, Training and Validation Steps. This covers Steps 3 and 4. So Step 3 in our design is the training loop. How do you actually train this architecture you just built? Well, first, you feed the model thousands of those labeled email examples and it makes a prediction. Second, you compare that prediction against the actual correct answer. Was it right? Was it wrong? Third, and this is really where the magic happens, when it is wrong, the model adjusts its weights using loss functions and backpropagation. It's kind of like tuning a guitar, right? It calculates its error and tweaks its internal dials just a tiny bit to get the perfect pitch for next time. And fourth, you repeat, again and again. The crucial takeaway here is that this iterative loop, making mistakes and adjusting, is exactly how the model actually learns. But, just learning isn't quite enough. We have to know it learned correctly. So Step 4 is validation. You always hold out a separate validation set of data that the model hasn't seen during training. You use this fresh data to check whether the model is genuinely learning the underlying patterns, or if it's just overfitting. Overfitting basically means it just memorized the training data, but it's going to completely fail out in the real world. If your validation performance is weak, well, as the designer, you've got to go back to the drawing board. You might need to adjust the architecture, tweak the learning rate, or maybe just gather better features.
Now for Section 5, defining true AI success. Let's look at Step 5 metrics.
I want to pause and pose this question directly to you. What actually is success for a spam classifier? I mean, it's pretty easy to assume that overall accuracy is the only thing that matters, right? Like, if it gets it right 99% of the time, it's a massive success. Well, not exactly.
Step 5 is all about establishing your success metric, and this requires some highly nuanced evaluation. Accuracy? Sure, that measures overall correctness. But for a spam detector, you also care deeply about precision, which basically means not crying wolf, and recall, which means not missing the wolf and it's actually standing right there. And most importantly, you have to measure false positives. A false positive is when the model incorrectly flags a perfectly real, legitimate email as spam.
Why do those false positives matter so much? Because marking a real urgent work email, or I don't know, a message from your family member as spam, that is a serious mistake with actual real-world consequences. A model that catches 100% of the spam, but also throws away your most important emails is just, well, it's a broken model. So success isn't just about being right most of the time. Success is being right in the ways that actually matter to the end user.
Okay, our final stop. Section 6, thinking like a designer and system synthesis.
I want you to take a step back for a second and just look at what you just accomplished. You successfully connected AI basics and machine learning to gather your data. You used neural networks and deep learning to build your architecture. You applied training and validation to actually teach the model. And then you utilized loss and optimization to refine the whole thing. You aren't just memorizing a list of vocabulary words anymore. You are synthesizing information to actually build something. You're genuinely starting to think like an actual AI systems designer.
To really solidify this, here's your call to action, your mini project plan for week 2. I challenge you to sit down and write out clear, detailed answers to these 5 foundational questions for a totally new problem of your choosing. Number 1, what data do you need? 2, what's the architecture? 3, how are you going to train it? 4, how will you validate it? And 5, what nuanced metric actually defines success? I promise you, if you can write that plan clearly, you understand the core foundation of AI, and you are 100% ready for the next level.
I'll leave you with this final thought. AI is not just about knowing terms. It's about connecting them into a working system. That is the true art of design. So, as you step out into the world armed with these new tools, what impossible problem will your first AI system solve? Keep exploring, keep building, and we'll see you in the next explainer.